Good afternoon. My name is Sam McCarty. It is November 4th, 2025, and this is my chiral molecule video assignment. Here shown to you in 3D is my chiral molecule. The common name is L-DOPA, and the IUPAC name is 2S, 2-amino, 3,4-dihydroxyl, phenyl, propanoic acid. It is shown to you in writing here below. Now, looking at the functional groups of this chiral compound, right here you have a carboxylic acid, which is an oxygen double bonded to a carbon, single bonded to an OH group. Here on the second carbon in the carbon chain, you have a primary amine, a nitrogen single bonded to one and only one carbon atom. Moving on here, you have a phenyl ring. It's a derivative of a benzene ring with alternating single double bonds. However, the substituents on the outer here being hydroxyls make this a phenyl ring. Now, looking at the hydroxyl group, this is an alcohol functional group, as you have a carbon single bonded to an oxygen single bonded to an OH, so a COH. Now, let's get into the stereochemistry behind this L-DOPA. Right here, it has one chiral center with 4 different substituents. If it has one chiral center, that means it has one pair of enantiomers. However, since it only has one chiral center, it has no diastereomers. There are no diastereomers for L-DOPA. Now, if there were a molecule that has 2 chiral centers, then that would be a possibility. Let's prioritize these substituents to show you that this is the S enantiomer. Here, based on atomic mass, you have nitrogen, the number 1 priority, bonded to this carbon. Then you have hydrogen, which is pointing in the away position, and it is your lowest priority. Then you have 2 carbons, differentiated by this carbon has 2 oxygens, and this carbon is bonded to other carbons, making this substituent the second highest priority, and then the phenyl ring the third. So you have 1, 2, 3, and then you go in rotation around, and it is counterclockwise, making it the S enantiomer. Okay, now let's go ahead and look on paper at the image I have provided here of the R enantiomer of L-DOPA. This is done so by providing a mirror image of L-DOPA, and you get the right-sided enantiomer, D-DOPA. You would go ahead and do the mirror image and then prioritize the substituents to get you the R conformation. However, if I tried to superimpose D-DOPA onto L-DOPA, I would not be able to. They are mirror images but are not superimposable, confirming they are enantiomers. All right, lastly, with the isomers, here you have the hydroxyl groups. There is a possibility to have constitutional isomer if I move a hydroxyl group to a different position on the phenyl ring. An example, I move this from the third group to the second group. I'm changing connectivity. However, the molecular formula stays the same, making this a constitutional isomer. Now, what is the use for this molecule? Now, this chiral molecule L-DOPA is used in the combo drug carbidopa-levodopa to treat tremors, muscle rigidity, and spastic movement in Parkinson's patients due to a depleted dopamine level in their body. L-DOPA is the precursor to dopamine that has the ability to cross the blood-brain barrier. Once it does so, it is metabolized into dopamine and helps to replete the diminished levels in these patients, aiding symptom management. I hope you enjoyed this video assignment. I had a wonderful time doing it. I want to cite my sources. Information came from the National Center for Biotechnology as well as the Lumen Learning online textbook. I will provide these in the comments below. Thanks so much for watching.